Okay, next we have a fantastically interdisciplinary scientist, Tyler Volk, from right here at NYU. I think I first met him when I read his book. I was surprised to discover he was nearby, and I sought him out. He's got to come speak to my students. This book, Metapatterns, was ranging all over the idea of pattern in nature from many different perspectives and points of view. And I think his ideas will very much complement what we just heard from Philip Ball.
I really recommend David's new book on survival of the beautiful. And I've read Philip Ball's books and some of Rick Prum's papers. So from that you can see my studies have to do with patterning. And that's what I'm going to talk to you today. Now this is a work in progress. Presenting it to some of my students and doing some writing along these lines, but I'm basically trying it out on all of you here. So I want to ask, how did we get here? Starting with the elementary particles, starting with quarks. And I want to ask it in a certain pattern kind of way. And around step 9 or 10, and I do want to also do a nod to Ren Wexler and his work on convergence in human art and psychological systems as well, being part of this sort of paradigm of patterns. How did we get here? And in terms of steps, because one of the patterns I'm interested in is very general, which is systems are composed of parts, or patterns are composed of subpatterns. Now it's very general, and the reason I like it is because it can allow us to think about almost anything that you want to think about. And if you enjoy doing that, then this is a good way to get into it. And I wanted to say, so we know quarks build into protons and neutrons. We know the human body is composed of organs, and they're composed of cells. And so we know we can, sort of power of 10 idea, we go all the way down or we go all the way up. So I want to ask in a kind of repetitive sort of way, how many steps are there? And I think it's about 13 levels to go from quarks to sort of the modern world. And within that are these 3 realms. I'm going to use a concept called metapatterns. And this could be called the universe's quest for ever greater holasms. So here we go. These are the steps from down below 1 to 13 up above. I start with the particles in the standard model, and I'm going to end up with science is level 13. There are realms of physical law, biological evolution, cultural evolution, so there are groups of steps. What I'm going to do is walk you through these steps. I'm going to ask certain kinds of questions that have to do with relationships, new kinds of relationships that come into being. And then in like the last third of the talk, I'm going to inquire into generalizations and whether there are patterns across some of these steps that have to do with what I would call metapatterns. I want to make another nod to Jacob Bernowski, famous writer, historian of science and scientist who had the term stratified stability in his book and films, The Ascent of Man. Stratified stability is the same idea. The general pattern here is that we have an entity at level n that has some kinds of relationships, which are the lines going out of the circle. So there's relations at level n. This entity at level n participates through its relationships and can build up an entity of level n plus 1. And that entity level n plus 1 has relations. And the key here is that these relations at entity level n plus 1 are different from the relationships at entity n. And my idea that this must be how quarks got to modernity through the build-up entities, but also the coming into being of new kinds of relations. And this is could be thought of as a meta-pattern that repeats itself on different scales of nature, or different scales of the universe, or different scales of culture from the Big Bang. And if there are about 13 levels or 13 steps, that gives us, if we're trying to do a scholarship or science of pattern of everything, 13 cases to start comparing and examining. And many of these levels have multiple instances, as I'll show you later, such as the coming into being of multicellularity. And therefore, there are patterns within these various steps that can be examined as part of a research program. So first, the realm of physical law. I'm going to take you through the elementals, or elementary particles, nucleons, nuclei, atoms, and then molecules. 5 levels in the realm of physical law that I discern. The level 1 of the elementals, this is the standard model of particle physics, sometimes claimed as the most successful theory in the history of science in terms of some of its predictions. On the other hand, there's huge mysteries in here, such as mass. Why, if you've been reading the paper, they're trying to figure out, does the Higgs boson exist? And that is necessary for the explanation of mass in the current theory. But I just want to draw your attention here to the lines I've drawn around these 12 entities on the left-hand side, which are the elementary fermions. And I'm going to call them things because they can't be in the same quantum state in the same system. And they form what are really the things in space that are separate. On the right-hand side, what I call the relations, or what physicists sometimes call the fundamental forces, or more modernly, the fundamental interactions, are gauge bosons. And these things are the relationships. They mediate the interactions. They get tossed back and forth, actually, by the fermions to have relationships. So this is just the given. This is just what the universe gives us, some things and some relationships. And isn't that nice? Because we don't have to explain that. And if it weren't for this, if it was just things and no relationships, we wouldn't be here to talking about it. So this is the start. There are things and relationships right at the start. What happens next? Level 2, the nucleons. Quarks build up protons and neutrons. There's 2 up quarks and a down quark that makes a proton, 2 of the down quarks and 1 up quark that make the neutron. It's really, if you go into this stuff, it's really fascinating because it's not just that the gluons that moderate the color force and the color charges are just lines, but they interact with themselves. The gluons also have color charge, they interact with themselves, and you get quark pairs pairs and anti-pairs coming into existence. It's a huge cauldron, and just in the last few years, they've been able to do calculations and get the mass of the proton approximately within 10%. This was a big discovery. But the new relations here is that the color charge of the quarks extends slightly outward from the protons and neutrons. It doesn't end, but it's muzzled. It's highly reduced. So this is the color charge. There's nothing really new in that, but what's new is that it's been greatly reduced as it extends past the protons and neutrons. And I want to point out the free neutron has a lifetime of 15 minutes. The free proton is basically infinite. It's the true immortal that we have to honor in some way. So what happens at the next stage? We have level 3 of the nuclei, and I show here as a representative one the helium nucleus of 2 protons and 2 neutrons. Well, the neutron by itself in space decays into a proton and some other particles in 15 minutes. So the only reason in the 13.7 billion years since the Big Bang that we still have neutrons is because the neutron is in coordination with the proton and is prevented by the existence of the proton from decaying into a proton. It has to do with the energy changes in the energy gradient for decay. Also, the protons, you'd never have 2 protons by themselves bonding together with this reduced muzzled color charge that's actually attracting the protons, because the electric charge of the protons would be too bright and would fling them apart. But with the neutrons in there, leavening or kind of moderating the electric repulsive charge of the protons, you get a stable system, a binary system. It's a very important metapattern of the elemental system of 2. And what results from this you can get 92 naturally occurring kinds of nuclei with different numbers of protons. And so you have 1, 2, 3, 4. Carbon has 6. You get the periodic table in terms of the nuclei. So this is what gets born that's new. You now have 92 kinds of concentrated positive charge that comes out of this level 3, the nuclei. Level 4, I just wanted to say a word about the meditation on the particle zoo. This looks like a periodic table up here, and there's actually more than 100 kinds of particles, mesons of 2 quarks and baryons of 3 quarks that can be formed, but they're almost all, except for the proton and the neutron, highly, highly unstable. At least in our universe, it looks to me like we're just on the edge. We just got a couple things that were stable enough to carry on this process. So level 4, the atoms. Once you have nuclei, then you get the electron coming up from level 1, combining with the nuclei of level 3, and creating level 4, the atoms. This shows some of these shells of the electrons as they come into the atom, which is the mathematical solution to Schrödinger's wave equation for the hydrogen atom. They're very beautiful. The basic relation, the new relation that comes in here, is that there are the electrons that the atoms have, and then there's a lack. Either they can have an excess, or they can have not enough compared to filled shells. And it's that tension, this sort of binary tension between what they have and what they lack in terms of a filled shell, either they have too many or they don't have enough, that can create relations between the atoms and gives us level 5, the molecules. Oh, so I need to, so it gives us level 5, the molecules. I'll get to in a second. This is the periodic table that comes out of the existence of the atoms. And I want to mention a term which is going to come in later, which I coined, called an alphabetic holarchy. A holarchy is a system of parts making wholes. Those wholes are parts making more wholes. Sometimes people will use the word hierarchy. I and a few others like to use the word holarchy. And alphabetic means it's a certain kind of holarchy in which complex combinations are coming from ways of combining a small number of elementary kinds of parts. And that we see we have with the 92 kinds of natural chemical elements, because when we get into the molecules, it's millions, billions, actually trillions. People are trying to figure out what this protein universe is. So it's by this 92 kinds of atoms really gives us this world, allows us to be sitting here. Level 5, the molecules, you get different kinds of bonds. Then you get bonds between the molecules with this having and lacking dynamic, and you can get a truly crazy complexity of patterns, because now you can have 2 orders of magnitude of different kinds of forces that are being filled in, because the kinds of forces that the atoms have once they're in molecules with other atoms and other kinds of molecules are not exactly the same magnitude that they had when they were alone. So this system just builds on itself now. Once you get the alphabet level or the letter level of the atoms, you just get an explosion of possibilities, and that's the realm of physical law. And the explosion of possibilities happens so explosively that we get into the realm of biological evolution as molecules turn into prokaryotic cells, the origin of life. And a theme here, which I take the slogan for, the general idea from J.T. Bonner, a Princeton biologist, is that size can be a niche. We think of a niche being, the niche of nectar feeders for flowers, or the niche of flight, as we saw this morning. A new place in the environment, a new kind of nutrient. Bonner points out that size is a kind of a niche, because size offers opportunities for organisms. There's always sort of room to be bigger than something else, and that may give you opportunities. And that seems to be that's one major theme for the biological level. So level 6, prokaryotic cell. This shows one of these alkaline vents, which is a current candidate for what had been the origin of life. Inside this cross-section, these tiny cells in which some kind of chemical evolution went through. 3.5 billion years ago, out from these things presumably popped simple cells once they formed inside with DNA. The new relations here that come into being with the cell is that there is active input and output of matter and energy. And there's function that comes in being. So suddenly food has meaning. Waste, the concept of waste comes in. This exchange can be exchange of molecules, which can be DNA and genetic exchange, and some of these molecules can start becoming signals with each other, and we're building up towards sort of what was discussed this morning, now creatures signaling to each other. Prokaryotic cells led to eukaryotic cells in a relationship called symbiogenesis, which Lynn Margulis, who recently died, I'll be going to an event for her in March in Amherst, Massachusetts. But she really pioneered this idea of the proof, really, that the prokaryotic cells combined in a symbiosis and led to eukaryotic cells, which our bodies are made of, and these eukaryotic cells led to multicellular organisms. The new relations that came into being here were an enhanced ability for cells of the same species to modify each other's expression of their DNA, which led to the multicellularity. And I'm going to talk about prokaryotic multicellularity a little bit later. But I want to point out that the multicellular organisms, it's a fascinating pattern because it's not just what typically is the big three of the fungi, the plants, and the animals, but they're this zone of evolutionary, of adaptive advantages in either reproduction or feeding or defense that the possibility of multicellularity gave was also taken by some diatoms, which are kind of algae. It was taken by some slime molds. This is dog vomit slime mold. Usually these things are amoebas that live in the soil or the logs. You never even see them, but during the reproductive phase, they come together in kind of a multicellular body. The kelp is a kind of algae, it's not a plant, that also discovered independently multicellularity. And then we get into the animal world, and then here's a lizard. And the new relations, and this is where we really get to some of the ideas that Rick Prum was talking about today, is that the use of sight and sound, when we get to this level of system, now is something very different because it's not direct contact and exchange of molecules in a larger body. As these cells built up, they were always in contact with each other. Prokaryotic cells to eukaryotic cells to multicellular organisms. Now the relationships of the system can become, go through sight and sound while the organisms still stay separate from each other. You see, this is on the way to us. We're not there yet. We're getting there. Now you can have animal societies. This is another level in which there's multiple inventions. In the ant, termites and bees, you get breeding colonies of birds. You actually get cooperative breeding in spiders. This was discovered in sort of a convergent evolution that you can get advantages by being social with members of your same species many, many times, including our ancestors, our primates. And they have a special kind of dynamics that the anthropologists call fission-fusion dynamics, in which some of the primates and dolphins and elephants, since they have individual relationships and they're working out their relationships, but they also can go into smaller groups and larger groups and kind of work out these relationships. So they're very fluid. Probably had something to do with the fluidity in human social being. Now that's the realm of biological evolution. Now I want to point out the animal society does take us to something slightly different. We're about to take off because there is a loosening of the genetic leash, because now you have creatures that do not have the same genome. They have interest in each other's genome. They have lots of shared genetics, but they're not identical. So there's a little bit of a loosening of the genetic leash that takes place. And what's going to happen is that this is going to jump. This is the precursor for jumping into what I call cultural evolution, which is here. And we're going to go through Paleolithic bands, agricultural villages, states, and something question mark like global mind or the coming of being of science. Size is still a niche. Things are getting bigger. The systems are getting bigger. There's got to be reasons for it, but it's not biological evolution. It cannot violate biological evolution, cannot violate physics, but some of the dynamics of it have to do with cultural evolution. Level 10, upper Paleolithic bands. These bands were probably about the same size as ape bands, maybe similar to today's chimpanzee bands in terms of size. They were ecologically restricted to being relatively small size, but they got larger. We can see the largeness by some of these traditions, such as the Venus figurines that were found throughout Europe and parts of Asia. So there were certainly very widespread traditions. The archaeologists and paleoanthropologists think that full language was here by this time, and therefore there were dialect groups, and so these groups were no longer, let's say, like the chimpanzee groups today, in which the groups outside themselves are rival. There would have been bigger, larger associations of social being in this level 10 upper Paleolithic bands. Now, one of the ways that the anthropologists have looked at this buildup is the following: bands to tribes to chiefdoms to states. But there's a lot of debates about tribes and chiefdoms because they're not well defined. Bands seem pretty clear, states seem pretty clear. I'm going to take a middle ground by trying to look at parts forming wholes. What was really parts coming in forming a larger whole? I'm going to submit it was the agricultural village, because what happened here is something similar to the eukaryotic cell evolution. Humans combined themselves with plants and animals to form a larger system. Some people even talk about this as symbiotic relationships. The plants have now helped us, we help the plants, and there's also genetic modification of the plant and the animals to bring them into our system, into this sort of human plant-animal system in a symbiotic way. There's a lot of issues about the coming into being of agriculture. There's something called the paradox of agriculture, in which health apparently went down in people. It was not a no-brainer that, yeah, start growing plants and you're better off. It's not necessarily true. But agriculture did give one big advantage, which was the new relation that the internalized productive control allowed these systems to start being mobile and move into regions. And it was independently originated in probably 7 to 10 different areas, but then it could move into other areas and led to level 12, the state. And you could almost, this is ancient Sumer, but you really could just be walking there and feeling quite at home, as long as you're not a slave or something like that. The buildings are not, and in some ways, when I started thinking about this, I just kept feeling, I don't know if there's been any more levels since then. I mean, we're still in this. They had a ruler, we've got rulers. Is Putin going to win? Who's going to win the next? Who's going to be the one person to kind of govern us, right? It's not that different. And so in some ways, level 12 that came into being about 5,000 years ago in different places of the planet, this happened in different areas, has been the entity within which change happens. Like once multicellularity happened of the animals, there was evolution within that type. And there's been cultural evolution within the type of state. But I think there's been one more I'm going to mention. But first I'll just show you Mohenjo-Daro in Indus Valley. That's another one of these independent origins of the state. Mesoamerica, it actually happened before the Maya in that area of Mexico. But level 13, maybe I like this as level 13 because I'm a scientist. But Jacob Bernowski, oops, I'm going to go back. The most remarkable discovery made by scientists is science itself. Science itself, the process of science as a discovery. This must be compared with the invention of cave painting, so my level 10, and of writing, which comes into the States, level 12. One thing about science is that it's a social formalized new form of PVS. What's PVS? PVS is a generic recipe for evolution: propagate, vary, and select. It happened biologically, it happened culturally, and within cultural evolution, science could be seen as a formalization of this with the creating of hypotheses, the doing of experiments, the publication of results, the sending the papers out there, like either can or cannot get published. There's kind of a formalization of a process that mimics an evolutionary process to match your ideas to the state of the world. So this realm of cultural evolution took place, and I want to get I'm going to end with some thoughts on commonalities across these different levels. This is multicellularity. I want to emphasize that it was multiply invented or discovered. There's prokaryotes that went to simple multicellularity. I'm not discussing those today. The eukaryotes, I showed you the slime molds, but there's a number of different eukaryotes that went into what's called simple multicellularity. What the biologists call complex multicellularity is maybe 6 or 7 different independent times that these steps got found. So to my mind, that shows that there's something almost inherent in them, because I don't really have good language for this epistemologically, but it's almost like the concept was there, the possibility was there, evolution had gotten to a certain state, and then boom, 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 a whole number of independent lineages of creatures took that step and went into that new realm, into this new way of organizing. Now this idea of this meta-pattern of multiple invention was itself multiple, because it happened in the origin of agriculture, it happened in the origin of the state. It may not have happened in the eukaryotic cell. It looks like the eukaryotic cell was what it's called monophyletic, that the mitochondria, that was the ancient bacteria that became the mitochondria of the eukaryotic cell, probably was a unique event. But some of these steps that happen multiple times themselves could be looked at, and what do they have in common with each other. So I see a program here to look into types of meta-patterns, and so what Phil Ball was doing would be, we're talking about activation and inhibition as a general pattern that can be discovered by maybe even the inorganic realm. I mean, discovery in kind of a loose way, but certainly in the biology discovering this in some kind of way. So one can have within these steps, like within multicellularity, are there similarities in this multicellularity? For example, with the eusocial insects of ants, there's commonalities in what happened in the ants, termites, and bees in forming queens, reproductive dominant queens, independently within those three particular branches of multicellularity. There's also, you go across the steps and across the various realms. And I want to mention, I want to take a look at the origin realm of biological evolution and cultural evolution, which is the origin of life and the origin of the Paleolithic band. Because what these two origin steps have, the origin of biological evolution and the origin of cultural evolution, is that they both have an alphabetic hierarchy. Or life has the amino acids, 20 amino acids, that build into the billions of kinds of proteins of the millions of kinds of species. And the origin of culture, when language came in, had in spoken language phonemes. The English language has 40 phonemes. You can build into typically tens of thousands of words, really almost an infinite number of, well, you can do the math. At these two origin steps, there's a commonality of biological evolutions, propagate, vary, and select, having its engine as an alphabetic hierarchy of the amino acid letters, building into almost infinite complexity, a realm of near infinity. The cultural evolution origin of the Paleolithic bands having the spoken language with its finite number of parts getting combined in multiple ways to build near infinity as kind of an engine of cultural evolution. So there's been a repeating pattern of the prokaryotic cells and the Paleolithic bands, both establishing a PBS system with an alphabetic hierarchy, which is the origin of a realm. There's even an intriguing next step of the eukaryotic cell and the agricultural village being a kind of symbiosis of multi-species, which gives an increased power to that entity. And there's also some intriguing similarities between multicellular organisms and states. So with that, I want to end with, where do I see this being with regard to beauty? And what I see is that this, to me, this is beautiful in that this is the world we have, and like we can look at the Grand Canyon and look at all the layers and appreciate it, we can start thinking about these layers that have been put down sequentially in the nearly 14 billion years of kind of cosmic genesis that happened, forming these realms and these steps, and try to ask what kinds of patterns do we see there. And with that, I will close. Thank you for your attention.
Thanks a lot, Carter. When you started, I wasn't sure you could get through the origin of everything in 25 minutes, but you succeeded, so great. So we have a few minutes for questions.
Yes, in the green.
What's the next step in the next realm?
Yeah, the step in the next realm, if I actually follow this through, I would say that given that science found a PBS process within the cultural evolutionary process as a way to becoming more potent in the evolutionary process, I think it's similar to the brain of the animal with associative learning. I didn't get into that being a kind of a PBS process. To me, it looks like we may be jumping to a new realm pretty soon. Now, people have talked about artificial intelligence and things, but it may be as different from current cultural, it may be something we can't conceive. It may be as different from cultural evolution as cultural evolution was from biological evolution. And I think that's a really, I mean, think about it yourself. I think it's a great question. You know, what's next?
Okay, one more question.
Maybe over here, since the microphone's
Okay, fractal geometry, has that lent itself to your studies, fractal geometry?
Yeah, fractal geometry is in there. I haven't been working with it particularly because others do a lot of work on it, and I'm more interested in form and function pattern coming out of the biological. But it is interesting to me the way the alphabetic holarchy of a physical realm from atoms to molecules, the atoms being the letter level going to the near infinity level of the molecule, that those are two different levels in the physical realm, but within the biological realm, the first step of the biological world of prokaryotic cell has both the letter level of the amino acids and the near infinity level of the proteins within that level. So it's almost, there is kind of a fractal nature to that.
Okay, Tyler, thank you so much.
The elementary particles, starting with quarks. And I want to ask it in a certain pattern kind of way. And around step 9 or 10, I do want to also do a nod to Ren Wexler and his work on convergence in human art and psychological systems as well, being part of this sort of paradigm patterns. How did we get here? And in terms of steps, because one of the patterns I'm interested in is very general, which is systems are composed of parts, or patterns are composed of subpatterns. Now it's very general, and the reason I like it is because it can allow us to think about almost anything that you want to think about. And if you enjoy doing that, then this is a good way to get into it. And I wanted to say, so we know quarks build into protons and neutrons. We know the human body is composed of organs, and they're composed of cells. And so we know we can, sort of the power of 10 idea, we can go all the way down or we can go all the way up. So I want to ask, in a kind of, I want to make another nod to Jacob Bernowski, famous writer, historian of science and scientist who had the term stratified stability in his book and films, The Ascent of Man. Stratified stability is the same idea. The general pattern here is that we have an entity at level n that has some kinds of relationships, which are the lines going out of the circle. So there's relations at level n. This entity on level n participates through its relationships and can build up an entity of level n plus 1. And that entity level n plus 1 has relations. And the key here is that these relations on entity level n plus 1 are different from the relationships on entity n. And my idea that this must be how quarks got to modernity through the build-up entities, but also the coming into being of new kinds of relations.
Okay, and next we have a fantastically interdisciplinary scientist, Tyler Volk, from right here at NYU. I think I first met him when I read his book. I was surprised to discover he was nearby, and I sought him out. He's got to come speak to my students. This book, Metapatterns, was ranging all over the idea of pattern in nature from many different perspectives and points of view. And I think his ideas are very much complement what we just heard from Philip.
Really recommend David's new book on survival of the beautiful, and I've read Philip Ball's books and some of Rick Prum's papers. So from that you can see my studies have to do with patterning, and that's what I'm going to talk to you today. Now this is a work in progress, presenting it to some of my students and doing some writing along these lines, but I'm basically trying it out on all of you here. So I want to ask, how did we get here? Starting with, and this is could be thought of as a meta pattern that repeats itself on different scales of nature, or different scales of the universe, or different scales of culture from the Big Bang. And if there are about 13 levels or 13 steps, that gives us, if we're trying to do a scholarship or science of pattern of everything, 13 cases to start comparing and examining. And many of these levels have multiple instances, as I'll show you later, such as the coming into being of multicellularity. And therefore there are patterns within these various steps that can be examined as part of a research program. So first, the realm of physical law. I'm going to take you through the elementals, or elementary particles, nucleons, nuclei, atoms, and then molecules. 5 levels in the realm of physical law that I discern. The level 1 of the elementals, this is the standard model of particle physics, sometimes claimed as the most successful theory in the history of science in terms of some of its predictions. On the repetitive sort of way, how many steps are there? And I think it's about 13 levels to go from quarks to sort of the modern world. And within that are 3 realms. I'm going to use a concept called metapatterns, and this could be called the universe's quest for ever greater holasms. So here we go. These are the steps from down below 1 to 13 up above. I start with the particles in the standard model, and I'm going to end up with science is level 13. There are realms of physical law, biological evolution, cultural evolution, so there are groups of steps. What I'm going to do is walk you through these steps. I'm going to ask certain kinds of questions that have to do with relationships, new kinds of relationships that come into being. And then in like the last third of the talk, I'm going to inquire into generalizations and whether there are patterns across some of these steps that have to do with what I would call metapatterns.